All right, welcome to day 2. Today's warm-up we're going to do together. So we've got an equation of a line there in in slope-intercept form. So our general form is y equals mx plus b. The m spot, that's the slope. The b spot, that's the y-intercept. So the first thing we should do is plot a point at 4 on the y-axis. Then, because it's negative, we're going to move down first. Then move down 2 and right 3 to plot the next point. Okay, and you could keep going down 2 and right 3 until you run out of space. Then you could follow the pattern going backwards if you have room. So moving over to the homework from last night, first one you had to plot y equals x plus 2. So start at 2 on the y-axis. In front of the x is a 1, which is really 1 over 1. So you're going up 1 and right 1 to plot that. That's how we get the slanted line. Y equals 2 is a horizontal line with a y value of 2. X equals 6 is a vertical line at an x value of 6. Our base of this triangle is 6. The height is 6. So we have 1/2 6 times 6 to give us 18 units squared. In the second one, start at -2 on the y-axis. You're moving up 3 and right 4. Then you're drawing in y equals -2, a horizontal line that's crossing through the y-axis at -2. X equals 4, a vertical line crossing through the x-axis at 4. We now have a triangle that has a base of 4 and a height of 3, so 1/2 4 times 3 gives us 6 units squared. For our area, we have 2 triangles essentially, so you can just do 1/2 your base of 6 times your height of 3, and then double it, so we get 18 units squared. We have a parallelogram in 3, so after you plot it, you could do the base of 5 and the height of 12. 5 times 12 is just 60. Three B is where we start with our weirder shapes. So remember, we make a rectangle around it. Do the area of that rectangle, which was 20, and then subtract off the triangles that we don't want. And we purposely make the rectangle so they're right triangles. So we had 2.5 and 1.5 for those areas. When you subtract them off from the 20, we get 16 units squared. So any weird shape, just make a rectangle around it so that it's right triangles in the area we don't want, or you might have squares or rectangles outside there. But basically the area outside of our figure but inside the rectangle we made should always be right triangles or rectangles. So in 4A, make a rectangle around. It really ended up being a square because it was 5 by 5. Each of the right triangles had bases of 2 and heights of 5. So do the areas of each of those. You have the 25, subtract away the 5 for each triangle, give you 15 units squared. When you make your rectangle around the part in B, notice you have some right triangles and you have those squares. Well, each of the squares are the same size, they're 1 by 1, and each triangle is 1 by 4. So you have 4 triangles with an area of 2, 2 triangles with an area of 1, and the square was 25. So subtract those off and you end up getting 15 units squared. Just coincidence that it was the same. So that was it for the homework. We're going to start on page 7. Today's focus, we're going to do Pythagorean theorem, distance formula, and midpoint formula. So Pythagorean theorem you should have seen in middle school. So it is used in a right triangle, and the sum of the square lengths, the sum of the square of the length of the legs are the non-hypotenuse sides, is equal to the square of the length of the hypotenuse. So you can fill those in where those gray boxes were. And then this gray box, you've seen this before, a squared plus b squared equals c squared, where c represents the hypotenuse. Now the reverse is true as well. If a squared plus b squared equals c squared works, then we know it's a right triangle. So if we know it's a right triangle, we can use the Pythagorean theorem, but the Pythagorean theorem can also be used as a test to see if the triangle is right or not. So moving down to the bottom, let's practice that. We've got a right triangle. We know two of the three sides, so the third side can be found by using Pythagorean theorem. Identify which one's the hypotenuse. Our hypotenuse is the 13. So I'm just going to call the other one x. We'll have 7 squared plus x squared equals 13 squared. It does not matter which one you let be the a and the b. The legs are interchangeable. So we'll have 49 plus x squared, and 13 squared is 169. We'll subtract our 49 over. That'll give us x squared equals 120. We'll take our square root. First thing you want to do is just type in square root of 120. See if it comes out nice. So take a moment to do that on your calculator. You should have found that it did not come out nice. So therefore, we've got to do a menu number factor. If it had told us to round in the question, which it did not, then we could just type it in and round to wherever we need to round to. But if it doesn't say to round, we should be given an exact value, so we'll need to do a menu number factor. So do menu number factor on a calculator page, and you're only putting in the 120, not the square root. When we get that, we should have 2 to the third, so 2, 2, 2, 3, and 5. We circle any groups of 2, or pairs, I should say. One of them goes out front, and then the inside stuff stays in there. 2 times 3 is 6, 6 times 5 is 30. So 2 square root of 30 would be our third side in this right triangle. As we move over to B, notice the missing side is the hypotenuse. So we'll call that x. So here we're going to have 4 squared plus square root of 34 squared equals x squared. Four squared is 16. And when you square a square root, you get the number underneath back. So square root of 34 times square root of 34 is just 34. When we add those together, we get 50. And we'll take the square root. Take a second, put square root of 50 in your calculator, see if it comes out nice. Should have found it did not come out nice, so we'll do a menu number factor of 50 now. So for that, we should get 2 times 5 times 5. So we have a pair of 5s. One goes out front. So we'll have 5 square root of 2 as our hypotenuse side. All right, next up is the distance formula. And we're going to see if we can derive it using the Pythagorean theorem. So let's plot some random point around here, and we're going to call it x1, comma y1. And we'll plot some random point up here, and we'll call that x2, comma y2. And what we're looking for is we're looking for the length that is between those. Well, we're going to set up our distance formula using Pythagorean theorem. That base length is the difference between our x values. So we could call this x2 minus x1. Our height could be determined by doing your y2 minus your y1. And let's call this side d because that's what we're trying to find, the distance between them. So let's set up Pythagorean theorem. We've got to do our one leg squared plus the other leg squared is equal to our hypotenuse, which we call d squared. Well, we want to know what d is, so let's get d by itself. We'll just take the square root of both sides. So d is just equal to the square root of x squared, or x2 minus x1 squared plus y2 minus y1 squared. And this is what's called the distance formula. The distance formula allows you to find the length or the distance between any 2 points, and it's just coming from the Pythagorean theorem. So that's all we're going to fill in down in this box here. So you can do your d equals the square root of x2 minus x1 in parentheses squared plus y2 minus y1 in parentheses squared. Note the squared is outside of the parentheses. All right, so we're going to find the distance to the nearest tenth for these. So we're going to have d equals the square root. And it doesn't matter what you do for your x1 and x2 as long as you're consistent. So let's maybe just call this x1, y1, x2, y2. Okay, and you could reverse them. You just need whichever x you start with its y in the other one. So we'll do -3 minus a -4 squared plus, since we started with -3, the y we have to start with is the -4 minus the 11 and then squared. So this says we're going to go to the nearest tenth. So what that means is we can just punch this in the calculator exactly as we see. So our square root button is off to the left on the calculator. It is right with the squared button. So on your calculator page, everyone should be typing this in now. Do your square root and then put this in exactly as it looks. We'll give you 10 seconds to put that in and see what you get and round to the nearest tenth. All right, for this first one, we should have got that it was 15.033 and some other stuff. So the nearest tenth, that would be 15.0. You do have to include the 0 when you're rounding if it ends up in that spot. So doing the same thing here, we'll do d equals the square root. We'll start a parenthesis. We need to pick an x value to start with. Again, it does not matter which x value you start with. Just to change things up, let's start with the 1 this time. Minus the 3 squared plus. Because we started with 1, we have to start with its y value in the other part. So we'll have -2 minus 8 parenthesis squared. We'll give you another 20 seconds. Go ahead, punch that in the calculator, see what you get to the nearest tenth. So we should get 10.198 and some other stuff. The 9 bumps the 1 up to a 2, so we should get 10.2 to the nearest tenth. Now, you may see questions where this asks for the exact or it just doesn't tell you to round. If it doesn't tell you to round, you shouldn't be rounding. If we had done this without the rounding, we would have put just the part under the radical in the calculator, not the radical itself, and that would have given us square root of 104. We would have tried that, If it didn't come out nice, then we would do a menu number factor. Our menu number factor would have given us 2, 2, 2, and 13. We would have one pair of 2s that would go out front, and then we'd have 26 still left inside. So you only punch it all in right at the start if they want you to round. If not, put in the calculator the part that's under the radical but not the radical itself, and then you'll have to go through and do a menu number factor to simplify the radical. So our third new thing to work with today is the midpoint formula. So let's again take some random point, x1, comma y1. And let's take another point. We'll call it x2, comma y2. And we want to find the point that's right in the middle of it. Well, based on the ones I plotted, okay, that would be right in the middle there. And let's see, well, how can you find the coordinates of it? Well, notice the x value of this right here is halfway between our x1 and our x2. Well, halfway between would be the average. So we could add our x values and divide by 2, and that would give us the x value of this midpoint. And then we can do a similar idea for the y value. We could add the y's and divide by 2, because that's giving us the average of the y values, and that would put us right in the middle, because we're the x value that's in the middle and the y value that's in the middle. So let's go down to the bottom and we'll write that in the box. That is our midpoint formula. So you add your x's, divide by 2, and that gives you the x part, comma. Add your y's, divide by 2, and that gives you your y part. So you're just averaging the x's and averaging the y's to get the midpoint. So let's look at an example of that. We have the endpoints of a line segment. We want to find its midpoint. So we're going to do 8 plus a negative 6 over 2. And we'll do 9 plus negative 3 over 2. Now I'm going to talk through this doing it without a calculator, but you could easily just punch it in the calculator as well. 8 plus a negative 6 gives us 2. 2 divided by 2 is 1. 9 plus a negative 3 gives us 6. 6 divided by 2 is 3. So therefore our midpoint is just 1, comma 3. All right, so now we're going to get a little bit harder. They give us the midpoint and only one endpoint. So let's imagine that this is our point D. Here's M, our midpoint. So G must be up here. We don't know its coordinates, so let's call it XY. And let's set up what our midpoint formula would tell us to do. Again, G and D were the endpoints, so we're going to use their coordinates. We would have adding our x's and dividing by 2. So we'll do 1 plus x divided by 2, because remember, we don't know G's coordinates. And add the y's and divide by 2. So 4 plus y divided by 2. Well, this little setup should give us the midpoint. Well, we know what the midpoint is, so that should equal negative 1, 5. So when you don't know one of the endpoints, but you know the midpoint, just call the endpoint you don't know xy, use your two endpoints to set up your midpoint formula, and then just make it equal to the actual midpoint. Well, now we're going to set up two equations. We're going to take the negative 1 that we know the x should be, and we'll set it equal to our x part, 1 plus x over 2. We'll take what we know the y should be, 5, and set it equal to 4 plus y over 2. Well, now we can just put these each over 1 and cross multiply. 1 times 1 plus x is 1 plus x. Negative 2 times 2 is negative 2. We can subtract the 1 over, and that'll give us x is negative 3. Over here, we'll cross multiply. 1 times 4 plus y is 4 plus y. 5 times 2 is 10. Subtract the 4 over, and we get y equals 6. So our point is just negative 3 comma 6, and that was the coordinates for G. This type of question is a really common question in this unit. You'll see it. We're going to look at another one in a second here. You'll see it on your homework. You could see it on quiz tests. Okay, so you may want to star these ones. They are really common ones. So the next one, they give us our midpoint. They give us the coordinates of an endpoint, and we don't know the coordinates of point Y. So again, let's call it x comma y. We'll set up our midpoint using our two endpoints. So we'll have 2 plus x over 2, because we take the average of the x's. Then we'll have negative 3 plus y over 2, because we do the average of the y's. This setup should give us the midpoint, which we know is 4 comma negative 6. So let's take the x part of our midpoint and set it equal to the x part in the left side, so 2 plus x over 2. Take the y part of our midpoint and set it equal to the y part in the other one, negative 3 plus y over 2. We'll put them each over 1 and we'll cross multiply. 1 times 2 plus x is 2 plus x, and that's equal to 8. We'll subtract the 2 on both sides. That'll give us x equals 6. Cross multiply over here. You get negative 3 plus y equals negative 12. We'll add the 3 on both sides. That gives us y equals negative 9. So our coordinate for y we found was just 6, negative 9. All right, moving on to page 11. We want to find the length here to the nearest hundredth. Well, if you want to find the length, that means you want to find the distance between the points. So we want to think our distance formula that we saw earlier in the video. So that's d equals the square root of x1 minus x2 parentheses squared plus y1 minus y2 parentheses squared. That is something you're going to have memorized. Okay, it comes up on the Regents, not going to be on a formula sheet or anything like that. Doesn't matter which one you let x1 be as long as you're consistent and start with its y value. So let's maybe just do d equals square root. We'll start with 24 minus a negative 8 squared plus, since we started with 24, we got to start with its y value of negative 3 minus, and then you have negative 15 squared. Okay, so no, if you're subtracting a negative thing, you should have minus and then the negative number. That's a common mistake with these. Now, because we are going to the nearest hundredth, we can just punch in that entire radical, including the square root, as it looks. When we do that, we'll get 34.1760 and some other stuff. We want to the nearest hundredth, so we'll look at the next spot. We have a 6, and that'll tell us to bump up. So we have 34.18. If we move down to 7, we're given 2 points, and we want the point that will divide IB in half. Well, if you're dividing in half, that should be the midpoint. So we can just simply do our midpoint for this. We'll add our x's and divide by 2. We'll add our y's and divide by 2, because we're just averaging the x's and averaging the y's to find the midpoint. Again, I'm going to talk through it without a calculator, but you could easily just punch those in your calculator if you needed to. 20 plus 8 is 28, divided by 2 is 14. Negative 8 plus 12 is 4, divided by 2 is 2. So that means our midpoint is going to be 14 comma 2. So that's kind of like what we have right now. We had I and D, the originals, we just found M. Well, what we want to do next is we want to find the point that is a quarter of the way from I to D. So if that's halfway, a quarter of the way would be right here. So what we'll do for that is we'll just find the midpoint between M and I, because that was M right there, our midpoint. So using M and I, we'll do our midpoint formula. So we'll have 20 plus 14 over 2, and we'll have negative 8 plus 2 over 2. 20 plus 14 gives us 34. 34 divided by 2 is 17. Negative 8 plus 2 is negative 6. Divided by 2 is negative 3. So 17, negative 3 is the point that would be a quarter of the way from I to D. So our last one, if we go to 8, I'm going to draw that picture we just had. All right, wait. We're going to draw a similar picture here. So we have E and G now. So let's say this is E and this is G. If we want to find the point that's 3/4 of the way from E to G, we've got to find the midpoint first. And then once we have the midpoint, we would want the point that's from M to G right in the middle. So let's first do our midpoint. So we'll have negative 8 plus 4 over 2, comma 5 plus 9 over 2. Negative 8 plus 4 is negative 4, divided by 2 is negative 2. 5 plus 9 is 14, divided by 2 is 7. So that's our M. We want to use that and G, and if we find the midpoint of that, that'll give us 3/4 of the way from E to G. So we're going to do negative 2 plus 4 over 2, averaging the x's of M and G. And we'll do 7 plus 9 over 2, averaging the y's. Negative 2 plus 4 is 2. 2 divided by 2 is 1. 7 plus 9 is 16, divided by 2 . 7 plus 9 is 16, divided by 2 is 8. So that would be our point right here. That's 3/4 of the way from E to G. That's it for this video. Have a great rest of your day.